Hey everyone, my name is Diana,
My name is Dennis.
and this is our project, the Trailblazer. After looking at a bunch of NASA rovers, such as Curiosity and Perseverance, we have come up with new ideas of how to build our rover, the Trailblazer. This includes many new features, such as the updated claw, the camera, the antenna, and the MMRTG. We transferred our idea to a 3D model design by first hand sketching our model. Then we started experimenting in Fusion. Our suspension is taking slight inspiration from NASA's rocker bogie suspension design. This means that it's separated between the front and back wheels, so that when an obstacle occurs, the chassis stays on the same level while the wheels are moving up and down. Our claw is positioned in the middle of our rover to ensure a good balance. Our claw also extends up to 7 feet. This ensures that the rover can sample at any angle. It also has grooves on the inside of the claw hands so that it can precisely pick up any rock and specimen for analysis.
And here you can see our claw in action. The first part and the second part of the arm both move. It's able to turn 360 degrees, and the end of it is able to also rotate 360 degrees with the claws being able to pinch and pick up whatever is needed.
How does the rover know what to pick up? Thanks to our camera, it can identify the specific rock or material that is necessary for the mission. It can then emit a laser to destroy the material and analyze it with a spectroscopy. Here you can see our camera in action. It can rotate at fully any angle. Relying fully on solar panels is not reliable. Therefore, we have the MMRTG, or the multi-emission radioisotope thermoelectric generator. It basically converts heat energy from the decay of plutonium into electrical energy. These systems work for years on end, so that means our rover can stay on the mission for a long time. The antenna on our rover serves the purpose of communicating to other rovers on Mars about recent discoveries. It can also send communication signals to lander spacecrafts on Mars.
In our rover, the MMRTG is able to turn 360 degrees about its y-axis, and our antenna is able to rotate around this y-axis 360 degrees and move up and down 180 degrees to receive the best communication possible. One of the goals of this project was to make a lightweight rover, and in order to save weight, we made sure that the inside body was hollow. However, to ensure integrity, we created two cross beams on two different sides to make this body as strong as possible and lightweight as possible.
Most of the assembly on our rover needs a clearance fit because our rover needs to be able to rotate and have unrestricted movement. Our rover mostly has H8F7 tolerance because it can withstand medium speeds and pressures that the rover will withstand, and also supports a clearance fit, which is essential for our rotational parts.
This rover features 4 separate motion studies. Let's go over them yet again. Here we can observe the rover moving forwards. In this motion study, we can observe the claw in action, showing its ability to move down and pick things up from the ground. In this motion study, we can observe the movement of the camera, which allows the rover to be aware of its surroundings and communicate back to the Earth. And here at last, we can observe the motion of the MMRTG along with the antenna. This is another one of our motion studies. So in total, we have 4 motion studies that we have observed.